Live from the Key TV studio to your TV and on the web, it's Homework Hotline. Go to homeworkhotline.tv to ask your math or science questions.
Hi, welcome to Homework Hotline. My name's Dan Scofield. I teach science at St. Bernard's Academy.
I'm Beth Baker, and I teach math at McKinleyville Middle School in McKinleyville.
Great. Well, we are here at Homework Hotline. If you want to ask us a question about math or science, you can go to homeworkhotline.tv. A little bit different this time. You can click on one link will take you to the live stream. Another link will let you send in questions via email.
Yep, you'll find the email link. And if you're one of my guys and you're using your ebook, you can even go to the ebook and paste the homework question and paste it into the email and hit send, and then I'll do your homework for you.
Great. So
this one time.
Yeah. We'd love to answer your questions, so if you have them, please send them our way. We'll do our best. In the meantime, I've got some stuff to do about electricity. On Thursday, we'll talk about static electricity, and today we'll do a little bit on electric current.
Ooh. And so on Thursday, will you do the Van de Graaff generator?
Yes, we will.
Very exciting.
Mr. Pinkerton will bring his Van de Graaff generator in, and we'll play around with that.
Ah, that's great. So Thursday, you guys got to come back for that one. It's going to be excellent. Yeah.
But today, it looks like we have some...
And then I brought some math stuff, and so I thought I'd invite you to... so we thought we'd open with a few math activities. If you are at home, you could number a piece of paper 1 through 5. We're going to do some guessing, and the guessing is going to get progressively more complicated as we go. So we're going to start here, and we're just going to say how many puffballs. So that'll be your first one.
Oh boy.
And then if you want to just guess and remember your guesses, or we can write them down. So we're going to do 5 little estimations, and they progressively get more complicated. And then we'll reveal the answers, and we'll see how people did.
Great.
Okay, so would you like to start with the puffballs?
Sure, I'll start with the puffballs.
All right, it's taped shut.
So I'm not going to be able to open this. And I usually try on these ones to try to maybe estimate what one row might be. And I don't know. And it looks like it may be about 8. I'm going to guess that's maybe around 50 in a row.
Okay.
50 on one. Maybe a little more than that, actually. All right, 50 in a row, and then I multiply how many it goes up. So I'm just really quickly, 1, 2, 3, 4, 5, 6. I'm going to guess there's 50 times 6. I'm going to guess there's 300 puffballs in there.
Oh, but I'm still on the eraser. Let's see. I got to remember how to do this. What do I do?
That one you go.
Okay, and I'm going to go pen 3. And you said 300?
I'm going to go with 300.
Okay, good. I'm having a little trouble writing on this new board, but we'll just go from there. Okay, so at home, if you want to guess on the puffballs, and if you went to the Humboldt Math Festival at Adorney Center last year, this is exactly the same one. So some of you have probably already guessed this exact box. I bet you don't remember the answer, though. All right. Our second one is going to be a sum. So now we're going to think about how many cubes are in here. But we're going to do the sum. These are all number cubes, and we're going to say how much does it all add up to.
Oh, boy.
And the one advantage you get is I will hand you one, and they are all the same.
Oh, they're all the same, okay.
Yeah.
All right, so this is a 6-sided cube, and it starts with 5 and goes up to 10, right? It's 5, 6, 7, 8, 9, 10. That sounds like 6 of them.
Yep.
So 5 plus 6 plus 7 plus 8 plus 9 plus 10 is 19 plus 8 is 27, plus 7 is 34, plus 6 is 40, plus 5 is 45. So that's 45 on a cube, and then I have to guess how many cubes are in there. So 45 on a cube times however many cubes that is. Again, I'll do the same thing.
Yeah, and so now we have two
double
things.
Double chances of making mistakes.
Gonna calm
so
down.
5, 10, 15, 20, maybe 20. Let's say there's 25. Maybe I'm going to say there's 75 cubes.
Okay.
75 cubes times 45.
Okay, so 75 times 45. I can't get anything to work on this board, so obviously I need to work at that a little bit better. I wonder if it'll just let me do this. 75.
So 75 times 50. 75 times 50. 75 times 100 is 7,500. So it's half of that would be 75. 300 and 75 times 40. 75 times 50 is is 3,375. Okay.
This is how math teachers do it.
3375. I was going to get there. I was going to get the right. Said 3,500. 3,500, but let's just go with 3375. Sure, I'll go with 3375.
Okay, and I cannot for the life of me get this pen to work. Maybe you can make it go.
I got it working earlier today, so it's like that, and you just go.
You could be the pen
oops.
guy.
Oh, the pen guy, great.
Yeah.
Again, that's what you're doing now. How can? Oh, wait,
Yeah.
let's
Oh,
do
let's
width.
go for much wider.
Okay,
there we go.
Okay.
That might help.
Now, how do I get rid of that? Oh, there we go.
Okay. We're getting to learn the new board on the fly
3.
here today.
Oh, look, great. 3, 3.
So this is where we tape a piece of paper on the technology and write on it with a marker.
Oh boy. Okay, there we go. 3, 30.
We can't get it to work.
335. Hey, look.
I think you need one more digit.
335. 33350. Okay, there we go.
Okay.
3,350. All right, that's my guess on the
there
sum.
we go.
Very good.
Okay, so the hard part today is just writing it
Writing
down
on the
as
board.
it turns out. Okay. So,
And now it's getting harder?
So these are both counting, but this one was compounded by knowing the sum of all the surfaces
Good.
of the
I'm
dice.
glad you get your calculator out because I think I'm going to need any more.
Yeah, I think it's totally fine. And then the third one is I just want the length of this rope in feet, and maybe you could shake it out for people.
All right.
But you cannot take it out of the bag.
Oh, yikes. Okay.
Yeah.
So now I've got to have, now I have to go and estimate how many, if I pulled it out. So
Right.
how
So there is a ruler in the bag to help you kind of organize your thinking a little.
So that's about, okay, if I did a, oh boy. This is going to be a mess. If I straighten this thing out,
brain
how
ups.
long would this be?
Yeah.
All right. I think maybe about, I don't know, like one little bit. So this is pretty thick right here. If
Yeah, it
you
is
guys
pretty
can see
thick.
it. It's pretty thick in there. It's maybe about 5 layers of this, and then it's wound around each time. I'm going to say it's 14 feet.
Okay, 14 feet. Let's see if we can get a 14
In
anywhere.
feet you want it or not inches, right?
The guess was in feet.
In
yes.
feet, 14 feet, okay.
Going really slow and
Hey,
there.
it seems to
Look
like
at
that.
Okay, just go
Ooh.
super slow.
Okay, that's the, all right.
That's the
right.
third one.
All
Our
right,
guess is, okay. And now we're going to do the area of this piece of paper in square inches, and I've drawn a real square inch right here.
Oh, that's
so
a-
this is one. That's one real square inch.
So how many of those squares would
Uh-huh.
fit on that thing?
Yep. And then,
And
yeah.
so I would say it would be about, I'm just going to see if I can guess it from here. Oh, I'll go from here.
We don't have great contrast, but yeah.
I'll go from
There you
here,
go.
and it's about 1, 2, 3, 4, 5, 6. I'm going to guess how many gaps there are.
Sure.
This way. So I'm not going to. I'm going to be. How wrong can I be? 1. Oh wait. You know what? Look at that. You know what that square on the TV is pretty
I
close
was
to.
wondering if it was a
Pretty
square
close.
inch or not. I think it's
Pretty
bigger,
close.
but
It
yeah.
is bigger. Yeah. So
Yeah.
I can actually. That might be better rate estimating. 1, 2, 3, 4, 5, 6, 7, 8, 9 by 1, 2, 3, 4, 5, 6, 7, 8, 9, 13, 14, 15. So about 10 by. So it's about 150, and then I subtract those things off of there.
Okay.
I'm going to be so far off. 150 minus, well, let's just say minus, maybe about 112.
Okay.
112 square inches. Let's just go with that.
Okay. Let's see if it'll go. Nope. Gosh dang it. We are having trouble with the pen, people.
That's not even going.
Nope, it's not.
So 112. Okay.
Okay, 112. We'll just
We'll remember that. 112.
And then the last one is we're going to stay thinking about square inches, but we're going to move it to a more difficult surface, which is I'd like to know the surface area of all of these tennis balls, but still in square inches. So you can recycle your square inch thinking, but move it onto a more difficult surface.
Well, there are 9, looks like tennis balls in there.
Okay.
9 tennis balls. I get that right. So I got 9 tennis balls.
Okay.
So there.
Uh-huh.
And then the surface area of a sphere, it's like 4 pi r squared, am I right with that? 4 pi r squared? Okay,
Yeah,
4
good.
pi r squared. But of course I don't know, so that if I can figure out the radius of this thing, I can figure out each one. So the
Right.
radius of, I mean, I'm not a tennis player, I don't know what the radius of the diameter of a tennis ball is, so I can use tools? Okay.
Sure.
All right, so
Okay.
it looks like the radius is just over an inch.
Uh-huh.
And so, so let's just go with an inch. And so the radius, and so 4 pi, so r, 4 times pi is about 12. Let's just say 13, because there's a little more than a inch. So let's say each one is 13.
Okay.
So 13 times 9
Yep.
is
117?
117. So I'm going to say
Okay.
117.
And our writing has been kind of, it's
Hey,
gotten
look, it worked.
crazier and crazier
It
as
moved
we
over
went.
to the side.
Yeah, for some reason that worked. Okay, you ready to take a look at some answers?
Oh, sure.
In math class, we have kids present their degree of accuracy.
Okay.
But I think we'll let you off the hook today, and we'll just see how you didn't cheer. How's that? Okay. If you can get within 10% of an actual answer, that's usually considered to be really good. And sometimes when kids are stuck, I just have them give me the lowest ridiculous answer and the highest ridiculous answer, and then we find something in the middle to get some traction. Okay. Puffballs. 283. Well done.
Oh, out of 300. Okay.
Yes, you did great. Okay, the sum of all the dice added together,
Good.
2,970. So that's not bad. Oh, our answers just went away. I must have touched the
I think
board in
I
some
think
way.
I said 3350 or something like that.
Right, so at least you were in the right, like,
was
small
in-
4-digit numbers.
yeah.
That's awesome. The length of the rope
way
is
way off.
42.6.
So I'm that's a lot more ropes. I was way gone from that.
Okay. Area of the blob is 144 because this is a tessellated piece of paper that's just 12 by 12 inches. So I just cut it and moved it around. Yeah.
I can't remember what I said on that one.
And I think you recognized that it was a tessellation earlier today. And then of all the tennis balls is 176.6.
Okay.
So what's interesting is these two is the blob is very slightly smaller than all the tennis balls together, which I always thought was kind of, they're remarkably similar.
Yeah, all
in
the
surface
tennis balls
area.
add up to the
Yes.
blob.
Well,
Just
thank
about.
you so much for
Oh,
playing
yay.
our game today.
That was fun.
People always think estimation is how many candies are in the jar, and we can take it a lot further.
Right, right.
Yeah, and then think we talked about inches, square inches, the sum. Like we have a lot of vocabulary going on here too.
And I guess while I was doing that, I was my least sure one definitely was the rope. I had no idea how to go and estimate that one.
Yeah, I think people at the math festival when they did this one, they'd try and pinch the rope and try to line it up through
Right.
the bag. It never worked.
No. Okay, well, so that's okay. Well,
Yeah.
I-
All
it's
right,
good
so
it's
now
good to
we're
do.
going to play on your side
All
of
right,
the
no
table.
play on my side of the table. So what's going on here is I want to start by talking about batteries and
Okay.
how do you get a current to create a current, electrical current. And the first people working with batteries were putting metal objects into things, and they found that they could make a current by doing that. And so you can actually make a current by taking any kind of be an electrolyte and putting electrodes into it. Now I'm going to start with I'll start with a lime. Limes work pretty well. And the idea is you want to put two different substances because the way they work is that creates a chemical reaction inside the whatever you're using, and one goes on one side, one goes on the other side. Now, if you use the same kinds of metals, it doesn't create. We'll show this. It doesn't create as much of a current. So I'm going to use this is copper, some
Okay.
copper wire. I'm putting it inside the lime, and it's not very strong. So what I want to do is connect it up to this.
And so are we saying
multimeter?
that the inside of the lime, the juice and the pulp are going to finish? Okay. Are
Yeah.
going to finish a circuit?
What the inside of what the inside is creating is it's creating a chemical reaction, and it's actually causing ions to form and causing electrons to go to more to one side than the other side, and it causes them to go around.
Okay.
But we have a question.
Let me ask this question for Dan real quick.
Oh, boy.
Okay. This is a complicated one. You have a frog that is 6 millimeters long.
Oh, but it sounds like I need to write things
Yeah.
down. And I don't want to use it on the whiteboard.
And I will try to use the whiteboard, but maybe Dan can use paper and pen. Do you guys have a pen for him to use? So far, we have a frog that's 6 millimeters long.
Frog that's 6 millimeters long.
He's a tiny little
Sounds like a
thing.
math question to me.
Oh, no. I'm sure it's for you. Okay.
A frog 6 millimeters long. Okay.
Okay.
Okay. It can jump 70 centimeters into the air,
Straight up.
I suppose.
Wow.
He's quite an athlete.
That is super frog. Okay, 70 centimeters up.
Yeah. Which is how far a flea can jump. A flea is 12 milligrams. This is your student, by the way.
Gosh. Okay, so 12. Okay, a 12 milligram free. Wait, was it a 6 millimeter frog?
Yes.
Okay, a 12 milligram flea
Yeah.
can
So we
also
have-
jump 70 centimeters up.
Yes.
That's most of a meter. That's pretty good. Okay.
A flea is 60 times smaller than the frog.
Okay.
The frog is 60 times bigger than the flea, whatever.
By
60.
weight, is this in the milligrams?
I'm guessing it is by weight.
Okay.
Yes.
Smaller, okay. So
What force does the frog exert on the surface if it pushes off 4 millimeters?
wait.
So glad this is not my question.
Okay, so what force? So the pushing time happens in the first 4 millimeters, right?
I'm not sure about that.
Okay, I want to talk about how we'd go about solving
Yes,
this,
that's
rather than actually going to and go about the whole thing.
Okay.
All right. So first of all, we're going to get the mass of the frog. Because that's not too hard to figure out, because it's a 12 milligram flea, and the frog is 60 times the mass of the.
So 12 times. So 720.
Yeah. So right. So I'm just going to say 60 times 12, which is 720 milligrams.
Wait, then he's a really strange shape. 720 milligrams. How much is that? 7.2 grams?
It's 0.72 grams.
Oh, so he stayed tiny at 6 millimeters.
Yeah. So he's a small. Yeah. It's a small point. So it's 0.72 grams, which is 7.2 times 10 to the negative 4th kilograms. Because we usually, when we talk about forces, we want to get into kilograms.
Okay.
So 7.2 times 10 to the negative. So we want to get in kilogram the mass, and so you want to compare this, and then he's got to get to 70 centimeters up, and so from that point we can figure out what his acceleration is to get to that high.
Okay.
Right. So how much acceleration does he have to use to get 70 centimeters up? So which is 70 centimeters is equal to 0.7 meters, 0.7 meters, and so the thing that we all fight when we go up and we try to jump is we're fighting gravity, and that stays the same. It's going to have the same acceleration that you're going to be fighting the frog, the flea, and me, except when you get older, gravity gets stronger.
That is true, by the way.
And the ground gets farther away, but that's another story. But when it's going up, it's fighting that gravitational acceleration, which is approximately 10 meters per second squared. And so you can figure out. There are some formulas. I'm guessing this is a physics student. So
and are they formulas? Is that why you went for kilograms? Because that's the easiest way to apply the formula?
Yes.
Is that why?
Yes.
Okay.
And it's kilograms for mass, meters for distance, and then meters per second squared for acceleration. It's the ones. So we're always using the same numbers. You can convert those all into feet and everything else if you want to.
Oh yeah.
You want to do that, but then it
gotta
gets.
be math. Like who wants to do that?
So what you want to do is figure out how much acceleration did it take to go up 0.7 meters, and so how much acceleration did they have to get to to do that? And then so you want to go to solve that. How much acceleration did you have to go? I mean, one way conceptually to think about that is to say how much acceleration did it take to get to 0.7 meters up? How fast did you have to go in order to do that? What was your initial velocity?
Right.
Because every second you're going to lose 9.8 meters per second. So how high up can you go? And then you can use that. There's that formula, the distance. I guess distance in y equals 1/2 acceleration times time squared. So 1/2 gt squared is the way I think I'd solve this. And then so this would be the distance you went, and then your acceleration would be the distance you went. Then you could plug in values. I'd say, so my physics students, this is what I would do. Start first solving how long was the frog in the air for to get to that height, and then you'll have
that gives you the time.
That gives you the time, and then from that you can get the initial velocity from it, and then you would apply. Then you could take that how much acceleration they have to get to that initial velocity, and what they gave you you're accelerating for, I think it said for something like 4 millimeters or something like that. Was that question? It was like
the frog had a length of 6 millimeters.
But they were saying it jumped for like 4 millimeters, right?
Yes, if it jumps 4 millimeters into the air
To generate that.
force was needed to get to that.
Okay, it's right. It's in contact with the ground, pushing off of it for 4 millimeters. So then you can get it. You start by getting its speed it had to get to get to 0.7 meters, and then how long. Then you can figure out the acceleration to get during that 4 millimeter distance to get to that speed. So it went from 0 to whatever speed that was, and then you could figure out the acceleration, and then you could figure out how much force that was, because because the mass of the frog times the acceleration would equal the force. And then that's what I would go with on that one. So figure out how much speed did it have to jump with to get to that height, 0.7, which is a kinematics problem. And then I would figure out how much acceleration did it take over those 4 millimeters of jumping. And then you can figure out that's acceleration. So acceleration times its mass would be the force it pushed with. Great.
Whew, that was quite a question.
And you have another question.
Wow, you are a popular man today. You are earning your living.
All right, how does cyclic electron flow? And I think we're talking about photosynthesis here, right?
Must be.
Must be photosynthesis.
This was the question.
It's
How
your
do-
show. You get to decide.
This is how I know about it. With photosynthesis,
Yeah.
cyclic electron flow is, it'll show, okay, good. It's going to show you in the light-dependent reactions in photosynthesis, two things are made. One of them is a electron carrier called NADPH, and the other one is the ATP, which is energy. And so in photosynthesis in plants, so this is happening in the chloroplasts, it's making these two products from light. It's cool. It converts light to energy. It uses that to switch water to make light. It makes energy from light. It also makes this electron carrier called NADPH, which later on gets used in the Calvin cycle to actually construct sugars. And so what the photosystems use, they create equal amounts of ATP and NADPH when it does linear electron flow. And so what happens, though, is the Calvin cycle uses more ATP than it uses NADPH. And so in order to compensate for that, if there isn't enough of NADP plus around, it'll go through cyclic electron flow, which means it will make ATP using photosystem 1. It just goes through photosystem 1, but it doesn't make NADPH. It just makes ATP by doing that. So that's how it differs. It makes ATP without making NADPH because more ATP gets used in the Calvin cycle, which is the second part of photosynthesis, than NADPH.
And does this have anything to do with the amount of sunlight energy that a plant is getting at any given time, or does it always do it regardless of the amount of sunlight it's getting?
I don't think the amount of sunlight is going to affect whether it does cyclic or linear. It's just it will go into cyclic because it uses more ATP than NADPH. And
Okay.
Linear electron flow means that it's going to make the same amounts of each kind.
Okay.
And it does that, but then it'll circle around photosystem 1 and just make ATP until it catches up again.
Okay.
So that's all.
Well, thank you for doing all the heavy lifting today. Let's go back to poking metal rods into a lime. How's that?
Wait, let's just try that. So here we go, metal rods into lime. So what you can actually make an electron current. A battery with this. If you put the same metals in there, it's not much of you can't make much of a current because you want to have a difference in electronegativity, which means how attracted the material is to electrons. So if you make a difference, it's going to be a tug of war in there. In this case, the electrons are going to be more attracted to the copper side than they are to the zinc side. This is a galvanized nail which is coated with zinc.
Okay.
And then, so there's going to be a natural wave. Electrons are going to tend to flow away from the zinc and towards the copper.
Okay.
But they can't go through the lime to do it. The way to get them to do it is to actually create a circuit. And you do that by
We're going to complete the
by
circuit.
completing the circuit. And so now, this isn't strong enough to light up a light bulb. You can light up maybe a small thing with it, but you can show the current on this is a multimeter, and everybody should learn how to use one of these things. In this, there's a couple wires coming out. I can show the voltage in it, and I can show the current in it, how many amps I have. And I'm going to set it to voltage, and I have to have the wires in the right place to do that. And then I'm just going to show the how many volts we got with this by showing that. Let's see. We have to point this at the right thing. Is that right? I don't know if that's.
I'll adjust it. How's that one? You got it.
Okay, well, I connect up these things, and should be set to the right thing. So I'm going to just show how much voltage there is, and there's a difference.
All right, we're going to see if it reads up.
Okay. So
There we go.
It says negative. It doesn't really matter. That just means I have the wires hooked up backwards.
Oh, okay. Got it.
Negative or positive, 0.9495 volts on this. So that means that I do have I do have a current going here. There's stuff that will be,
Nice.
there's, the electrons are more attractive. They have to go around the outside. They can't go through the middle. But that's how you
Wait,
make
they can't go through the middle of the line?
the line. They have to go around the outside.
So we only have like 30 seconds left, but are you saying that electricity is going over the surface of the line?
No, it's
not
going
the-
through here. It's actually going around the. It would have to go around the outside in order
Okay.
to do it. The electrons have to flow. You have to connect up the two terminals in order for it
Okay.
to get actually
Got it.
something to flow. And that's how you.
Is there
you know,
any fruit or vegetable that would light up a little light bulb?
if I connected these in series, which is something I could have done, I could have had enough to maybe possibly do it. But
Oh.
yeah, you can try it at home.
It's amazing.